Let us now explore how do we write inverse of a function from the standard form of quadratic equation. Enjoy the journey of learning. Thank you. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll look into the solution of question number 2 from our final test paper 2024 MCR 3U functions. The question here is given f of x equals to 2x squared plus 8x plus 5, where x is less than equal to minus 2. Part A, determine equation of the inverse of function, and B is write down domain and range of this function. This is a very important question. During the semester, many students could not answer similar questions, and therefore the solution is kind of important for the final exam preparation. While those of you who want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. We also run summer school to prepare you for September. Join our classes for and get to know about our special programs. Now let's see how do we solve this question. We are given the function f of x equals to 2x squared plus 8x plus 5. We are also given that the domain of this function is less than equal to minus 2. Now, to find the range, what we know is that we need to find the vertex, right? And this parabola opening upwards, once we find the vertex, we can find the range also, right? So it's a good idea to write this in vertex form. And that is also a must when you want to find the inverse of a function. You get the idea. So if you are given equation in the standard form, make a note, convert it into vertex form, and then find the inverse. So let's do the needful. We'll do completing the squares, taking 2 as common factor from the first two terms. We get x squared plus 4x. Keep 5 aside. Now we have to add and subtract half of 4 square, which is 2 square. Now adding and subtracting same term does not make a difference. However, the three terms here make a perfect square, which we can now write as x plus 2 whole square. Get the idea? And we have minus 2 square means minus 4 plus 5. Now, let's open the bracket, write down the function. Now, this is the vertex form. 2 times x plus 2 whole square minus 4 times 2 is minus 8 plus 5. Or we can say f of x equals to 2 times x plus 2 whole square minus 3. So we know now that this vertex is at minus 2 minus 3. And therefore, domain is already given. Left side means we're looking into the left side of this graph, right? So what is the range of this function? Well, the range of the function itself is y belongs to real numbers, where y is greater than equal to minus 3. Clear? Now, once you know domain and range of the function, you can at least write domain and range of the inverse of function. See, it is kind of important to understand that every question has got marks associated, right? So, if you are not able to find the inverse of a function, at least you can write the domain range. Okay, so let's do that part first. So, we'll write domain of inverse function as what? Well, the range now becomes the domain, right? So, x belongs to real numbers where x is greater than equal to minus 3. Makes sense? Perfect. And as far as the range of inverse is concerned, it will be y belongs to real numbers where y is less than equal to minus 2. Perfect. So now we have the domain and range of this particular function, right? So I hope this part is clear. Now, once we have the vertex form, we can find the inverse. So on the next page, we'll begin with the vertex form, starting with this particular equation, right? And then swapping x and y to find the inverse. Remember, inverse is a function, right? Because we have restricted the domain as x is less than equal to minus 2. Clear? So we have our function which is 2 times x plus 2 whole square minus 3. So let's go to the new page. We can write this function as equal to f of x equals to 2 times x plus 2 whole square minus 3, right? Okay, so to find the inverse, let's swap x and y. You think this is written as in the form x and y, it is 2 times x plus 2 whole square minus 3. Now see, how do we do inverse, right? So first step, swap x and y. So we'll write this as x equals to 2 times y plus 2 whole square minus 3. Now we need to isolate y. So it becomes x plus 3 equals to 2 times y plus 2 whole square, or x plus 3 divided by 2 equals to y plus 2 whole square. So from here we can write y plus 2 equals to, we'll square root both sides, right? Square root of x plus 3 over 2. Now it is important to note that since we have restricted the domain as x less than equal to minus 2, that is on the left side, so the inverse will be kind of like this. You see that? And therefore, we are going to take a negative sign here, not positive and negative when we square root. So now we can rewrite y as equals to minus square root of x plus 3 by 2, and this 2 becomes minus. Is that clear to you? So you can see from here that this is a square root function, right? And this square root function has a vertex which, so now we can, let me rewrite this as y equals to minus, within square root I'll take half common, right? X plus 3. Is that clear to you? Minus 2. Now that becomes more familiar. Perfect. So so now we can say that this graph will be with the vertex here at minus 3 minus 2, right? and going downwards as shown here, right? And from here we can say that the domain of this particular function, which is inverse, is x belongs to real numbers, where x is greater than equal to minus 3, right? And as far as the range is concerned, y, let me write range is y belongs to real numbers, where y is less than equal to minus 2. Makes sense, right? Just as we concluded earlier. So that is how we can find the inverse and write the domain range. But the idea is if you are not able to find the inverse, at least you can write down the domain and range, right? So that's another part which is very important for us to understand as we did here, right? We did get our domain range without even finding the inverse of the function. That is very important for you to understand. It makes difference sometimes. So with that, we come to an end of this particular solution. I hope you understand and appreciate it. Feel free to write your comments and share your views. Thank you and all the best.